Hello, this is Patrik Yandola, and this is my EECE Fall 2020 final project. Let's get to the demo. As you can see, when the code starts, no LEDs light up, and my name, Patrik Yandola, followed by Fall 2020, will run across the 7-segment displays. After that is done, it will start writing my name and Fall 2020 again, and will continue to do so indefinitely until the program is ended. Now let's look at how the keypad works. So as you can see, right now none of the LEDs lit up. Let's hold down the key button 1. As I hold it down, no LEDs will be added, but a sound will be played. Once I let go of 1, 1 should be added to the LEDs. As you can see, the sound kept playing while I held down 1, and now 1 is added to the LEDs. Let's do that again. Once I let go of 1, the LED value should be 2. And as you can see, it is now 2. Now I'll try it with a different note. Say, for example, keypad 2. 2 should be added, and the current value of LED is 2, so 2 plus 2 is 4. A different tone played, one associated with keypad 2, and as you can tell, the LEDs are now at 4. Now, for example, let's play a key button A, which is equal to 10. So 10 should be added to 4, the result should be 14, which should be 8, 4, and 2, and a note associated with A will be played. And there you go. The value is 14 and note A was played. The only one that's different from all the other keypads is 0. When you press 0, nothing is added and no note is played, as demonstrated here. Now let's do some other ones just to show you that they all work. 9, D, star. And that is how my final project works. Now I'll talk about some issues I faced when doing this project. For this, I'll be showing you my code. Well, here we are, and let's go through it. One of the first issues I faced when trying to code this is the way I was reading the keypad. To properly read the keypad, we have to set the column values of the keypad 4 different times. The issue with that was I was not waiting for 10 cycles between setting those column issues and taking the readings. Thing is, electricity doesn't travel that fast because all the commands are run through at 1 Hertz, and it takes at least 10 for them to change. So what I had to do is go into my keypad and add a cycles period of 10, 20, 30, and 40 cycles between the readings. This way, electricity would have enough time to travel and set the columns so that my readings would be updated properly. A second issue I ran into was when I was trying to add debouncing to the buttons. While my code seemed right, for some reason debouncing kept not working. The reason for that, as I later found out, is I was using the wrong amount of time. What you're supposed to do is wait 10 milliseconds. Now, 1 second on this D1 SoC board is equal to 50 megahertz. That's the same as 15 million hertz. 50 million hertz divided by 1,000 gives you 50,000. So 50,000 is 1 millisecond, and we had to wait 10, so we should have waited 500,000 hertz, 500,000 cycles. Instead, I was waiting 50,000 cycles, which was messing up my debouncing because not enough time was given for the debouncing to happen, and I kept getting double readings. Now, the third and final issue that I would like to discuss was the way I did the rotating display. So my goal was to reuse as much of the old code as we had. And in one of the previous labs, we already had a module that would display our name on a single hex, on a single 7-segment display. But now we needed to display on all 6. Easy enough, make 5 more and use them as submodules, right? And that is in fact what I ended up doing. As you can see right here, I create 5 automatic displays. Now the issue is, what we want to do is have our name and full 2020 slide across the 7-segment displays to the left. To do that, they must be delayed. So for example, the very first 7-segment display begins displaying immediately, while the second one does a second later, and so on and so forth. So you get the notion of the name going across the board to the left. Now, I kept trying to do something with our original automatic display. Automatic display had a timer, and it would move through our name and full 2020 and all worked perfectly. The only issue was, how do you add the delay? Well, my attempt was to pass something to automatic display that would change the progress to a negative value. So say -5 if it was hex value of 5. So the very last one would start 5 seconds later, -5. The first issue I ran into is that negative numbers in Verilog are represented as a 2's complement. So for example, when I was trying to pass a negative representation of, say, -5, I need to have 16 bits or more instead of the 5 bits I was passing because of the second's complement representation of negative numbers inside of Verilog. The second issue is that I was trying to change the value I was passing inside my rotating display. But that would mean that I would have to set it to like a register, and you cannot pass a register as an input. You have to pass a wire to other submodules. The reason my thinking was flawed is that I kept thinking, how do I offset it? Make the beginning point negative. What I really should have done is thinking, how do I delay it? Once I started thinking about how to delay it instead, it all worked out. Now I pass a positive value called delay to my automatic display. And the automatic display has just a few lines of code, then wait. And if the progress is equal to the delay, then it will go. So, when the delay complete is less than the delay, it will actually start. So this way I pass the delay of 0, delay of 1, delay of 2, delay of 3, delay of 4, and delay of 5. So for example, the very last 7-segment display will not start doing anything until 5 seconds has passed, until delay complete is equal to delay. And that is how I fixed it and got it to write from right to left. This was my final project. Thank you very much.